In this building, they are making the rarest and most expensive material in the known universe, antimatter.
A new chapter, Run 3 of the Large Hadron Collider, will give us collisions.
The Large Hadron Collider, a remarkable achievement in the field of particle physics, has allowed scientists to delve deep into the fundamental aspects of our universe. Its origins can be traced back to 1977, when Sir John Adams, the former director of the European Organisation for Nuclear Research, CERN, proposed the construction of an underground tunnel capable of housing a particle accelerator with the capacity to reach incredibly high energy levels. Over the years, it has helped uncover the secrets hidden within the smallest constituents of the universe. However, there have been unexpected and unsettling developments at CERN that have raised concerns, particularly among individuals like David Icke. What are Icke's views on CERN, and should we be worried? Let's find out. CERN, in collaboration with an extensive network of over 10,000 scientists and numerous universities and research institutions spanning multiple countries, embarked on the construction of the world's largest and highest energy particle accelerator from 1998 to 2008. This remarkable machine, known as the Large Hadron Collider, LHC, is housed within a 27-kilometre circular tunnel located approximately 175 metres beneath the border separating France and Switzerland near Geneva. In 2010, the LHC celebrated a significant milestone by achieving its first collision, reaching an unprecedented energy level of 3.5 tera-electron-volts per beam, surpassing the previous world record. Subsequent upgrades further elevated its energy capacity to an impressive 6.5 tera-electron-volts per beam. The collider comprises 4 specific points where accelerated particles intersect and collide, and it is equipped with 7 specialized detectors strategically positioned around these collision points. While the primary focus of the Large Hadron Collider revolves around proton-proton collisions, it also possesses the capability to accelerate heavy ion beams. Each year, a dedicated month is allocated for experiment-led collisions, including proton-led collisions. The core objective of this colossal scientific endeavour is to provide experimental validation for the predictions put forth by particle physics theories. Crucially, the LHC plays a pivotal role in the measurement of the Higgs boson's properties and in the exploration of a vast array of new particles postulated by supersymmetric theories. The term hadron refers to subatomic composite particles comprised of quarks bound together by a strong force, akin to how electromagnetic forces hold atoms and molecules together. Notable examples of hadrons include baryons like protons and neutrons, as well as mesons such as pions and kaons. These hadrons were initially discovered through cosmic ray experiments conducted in the late 1940s and early 1950s. Fundamentally, a collider operates as a specialized particle accelerator by combining 2 opposing particle beams to facilitate controlled collisions. While constructing such colliders can be a formidable challenge, they serve as invaluable research tools in the field of particle physics, justifying the significant efforts invested in their development. Their unique ability to achieve higher center of mass energies compared to fixed target setups makes them indispensable. As a result, scientists can scrutinize the aftermath of these collisions, gathering evidence and insights into the subatomic realm's structure and the fundamental laws governing the universe. The Large Hadron Collider was reactivated in April 2022 following a substantial 3-year hiatus dedicated to extensive upgrades and maintenance. This pivotal moment marked the commencement of a remarkable scientific initiative known as Run 3. However, during this run of the Large Hadron Collider, scientists encountered an intriguing and puzzling event. On July 7th, an unusual phenomenon occurred within Earth's magnetic field. Unlike brief and fleeting lightning flashes, this enigmatic event was a persistent crack that remained open for an astonishing 14 hours. This extended opening allowed potent solar winds to flow through, leading to significant geomagnetic storms that in turn gave rise to captivating and awe-inspiring auroras. The sight of these geomagnetic storms was so mesmerizing that scientists couldn't help but be entranced. However, the question lingered: what caused this sudden crack, and what connection did it have with the Large Hadron Collider? Remarkably, the appearance of this crack can be attributed to a rare phenomenon known as a co-rotating interaction region from the Sun, abbreviated as CIR. These CIRs are expansive plasma structures that form within the low and middle latitudes of the heliosphere, where rapid and slower solar wind streams converge. The heliosphere encompasses both the Sun's magnetic field and the solar wind. Similar to coronal mass ejections, CMEs, co-rotating interaction regions are ejected from the Sun and directed toward Earth. Inside these regions, shock waves and compressed magnetic fields can create turbulent space weather, often resulting in the mesmerizing display of auroras. In the early hours of July 7th, this particular CIR impacted Earth's magnetic field, leading to a sustained G1 class geomagnetic storm. According to assessments by the National Oceanic and Atmospheric Administration, NOAA, analysts observed that a coronal mass ejection was embedded within the solar wind preceding the co-rotating interaction region. The pressing question that emerges is whether the public should be alarmed by this occurrence of a crack in the Earth's magnetic field. According to experts, there is no need for undue concern, as cracks in the magnetic field are relatively common. This magnetic shield plays a crucial role in protecting our planet from solar storms emanating from the Sun. While many cracks in the field tend to open and close quickly, recent instances have shown that some of these cracks can remain exposed for extended periods, spanning several hours. However, the story doesn't end here. In the vast expanse of the cosmos, the fundamental forces that govern our world continue to conceal mysteries. In our known realm, 4 dominant forces hold sway: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Yet whispers from the cosmos allude to the existence of a 5th force, hidden from our view and awaiting discovery. Speculation links this 5th force to dark matter, the enigmatic substance that constitutes approximately 27% of the universe's content. Some propose that this elusive 5th force may be intricately connected to the existence of extra dimensions. As the quest for answers intensifies, so do concerns voiced by those who ponder the potential repercussions of meddling with the divine. The Large Hadron Collider, the instrument that aids our understanding of the universe, has become entangled with fears of inadvertently triggering catastrophic events leading to our extinction. There are various theories and speculations surrounding the Large Hadron Collider, each more intriguing and, at times, alarmist than the last. Some individuals believe that the LHC is a concealed gateway to an otherworldly realm, with the potential to unleash demons and nightmarish creatures into our reality. Others have suggested that the LHC hides a formidable weapon capable of annihilating the entire planet with a mere flick of a switch. There are also those who entertain the idea that the LHC is part of an elaborate government conspiracy aimed at manipulating minds and turning people into unthinking automatons. Furthermore, some assert that the LHC is involved in deeply sinister endeavours, contending that the particle collisions within it are part of a covert government experiment to establish a new world order where only the elite would survive. Adding to the concerns about CERN, David Icke, an English conspiracy theorist, former footballer and sports broadcaster, has voiced his apprehensions. Icke, who has authored over 20 self-published books since the mid-1990s and has spoken in more than 25 countries, had a pivotal moment in 1990 when he visited a psychic. The psychic told him that he was on Earth for a specific purpose and would receive messages from the spirit world. This led Icke to proclaim in 1991 that he was a son of the Godhead and predicted imminent devastation due to tidal waves and earthquakes. Icke's theories also revolve around a network of interbreeding families dating back to ancient times, which he claims are manipulating events to establish a centrally controlled Orwellian global state. His extensive research spans more than 2 decades and over 40 countries, connecting seemingly unrelated individuals, events, and topics to illustrate a grand conspiracy. He contends that the elite are actively working towards shaping a new world order. So, is this really true? Central to the apocalyptic hypothesis surrounding the LHC is the concept of a false vacuum, a theoretical state of space where energy does not rest at its lowest level. The concern is that the LHC's experiments could potentially create conditions conducive to the emergence of a false vacuum, leading to the formation of black holes capable of engulfing entire galaxies. While this doomsday scenario may appear far-fetched, it is not entirely impossible. And while the possibility of creating black holes within the LHC is considered unlikely, the potential consequences of a false vacuum are so severe that they cannot be dismissed. The concept of a false vacuum is intricately linked to the Higgs field. For a false vacuum to transition to a lower energy true vacuum state, the Higgs field must overcome an enormous energy barrier through quantum tunneling. This barrier's magnitude is so vast that the transition would likely require a time frame much longer than the current age of the universe. In essence, while the theoretical collapse of the universe is a concern, practical implications are not immediate. The Higgs field exists in a metastable state, temporarily trapped in a false vacuum, which means that while the risk of a catastrophic scenario is real, it does not pose an imminent threat. Another controversial aspect of CERN's research pertains to its role in creating antimatter. This concept was depicted in the movie Angels and Demons, where fictional scientists at CERN produce a gram of antimatter, subsequently stolen by the Illuminati for nefarious purposes. In reality, CERN does produce antimatter using its antiproton decelerator, generating approximately 100 billion antiprotons daily. However, it's important to note that fundamental particles are exceedingly tiny, and this quantity of antiprotons only amounts to about 0.1 picograms. 1 picogram is equivalent to 1 trillionth of a gram. In other words, it would take billions of years for CERN's machines to produce a whole gram of antimatter, not to mention the immense amount of energy required to contain such antimatter within an electromagnetic trap. As for concerns about antimatter and matter annihilating each other in a violent event, the antiprotons produced by CERN travel at nearly the speed of light and are almost instantaneously absorbed by the detectors. Additionally, the mass present does not contain nearly enough energy to impact our macroscopic world significantly. We'd love to hear your opinions on this topic. Please share your thoughts in the comments section below.